That TV looks familiar.
Isn't that Mr. Fresco's?
Yeah, I bought it from him.
Whoa, look at the shows on this thing. Good Morning Acceleration, Harry Potter and the CMS of Secrets.
And The Big Bang Theory. They're also scientific.
Hey look, Teen Momentum. Let's watch that. On this episode of Teen Momentum, one irresponsible teenage mother left her baby in a stroller at the top of a hill. Let's see what happens. The stroller gathers speed as it goes down the hill, which means its velocity is also increasing. According to the equation P equals mv, in which P is momentum, m is mass, and v is velocity, the stroller's momentum must be increasing too. Momentum is a measurement of an object's motion and mass. Now the stroller is approaching a garbage can. The law of conservation of momentum indicates that the stroller's momentum will not change after it hits the wall. Since the combined mass of the stroller and the baby will not change after the collision, the velocity must still be the same. However, the stroller will be traveling in the opposite direction, so the velocity will be negative. Therefore, the total momentum of the stroller will be twice the quantity of mass and velocity. Let's watch again in slow motion. The stroller's momentum didn't change. Now, let's see what teen father Trevor White is up to. Trevor White was only 13 years old when he impregnated his ex-girlfriend, Cara. Now he looks after their daughter, Krista May. Today, he is teaching her how to play soccer.
Ugh.
Get up now, you stupid girl.
You kicked it too hard.
You're an accident. That was an accident. Let's try this again.
This is a great example of an inelastic collision because the ball and Krista May collide and move as one. This can be shown in the equation. M1 represents the mass of the ball and V1I represents the velocity of the ball before it hits Krista May. Likewise, M2 represents Krista May's mass and V2I represents her velocity before the ball hit her. On the right side of the equation, VF represents the velocity of both Krista May and the ball as they move together.
You catch like a girl. What type of daughter are you? You suck.
I'm gonna hurt you.
You won't.
Now this is an elastic collision because the ball and Trevor collided but moved away in different directions. Momentum is still conserved. In this equation, M1 is the mass of the ball and V1I is the initial velocity of the ball. M2 is Trevor's mass and V2I is his initial velocity. The right side of the equation represents what happened after the collision. Now V1F is the ball's final velocity and V2F is Trevor's final velocity.
Ouch. This is getting too violent for me. Let's watch something else.
Got a secret, can you keep it? Swear this one you'll save. Better lock it in your pocket, taking this one to the grave. If I show you, then I know you won't tell what I said. 'Cause two can keep a secret if one of them is dead.
Oh, hey, Elon.
Oh, hi, Electron. How was your weekend?
It was okay. I went to the bubble chamber to catch some rays.
Oh, you should have invited me. I love cosmic rays.
Did you particles see the newspaper today?
No, what did it say, Talon?
Today's the anniversary of the day you know who went missing.
You mean Higgs?
Particles, come on. I know she'll turn up. Maybe she just went on a trip. Not everyone wants to stay in Leptonville, you know.
Or maybe she was kidnapped, Neutrino. For all we know, she might not exist.
Don't say that. You're so negative.
Well, what do you expect, Neutrino? We all have -1 charges here. You're the only neutral one.
Yeah, at least we're not like everyone else.
Okay, guys, stop it. Let's get back to serious things.
So I heard Mr. and Mrs. Boson have moved out of their house.
What? Why?
Well, probably because they don't want to be reminded of their missing daughter.
Have you guys noticed that they have a pretty weak relationship? It's kind of sad.
Is it that late already? I've got to get home before my parents start to worry.
Same here. Caroline, can I get a ride in your Accelerator? Sure, let's go.
Higgs, where are you? I'm all around you. You just have to find me. H.
You might have lost weight, but you'll always be the biggest lepton to me. H. Who's H?
Hey, Talon, what are you doing here?
Your mom let me in. Anyway, I got a text, and I think it's from Higgs.
You too? I got one earlier saying that she's all around us. Do you really think it could be her?
I don't know. I just got another text from Higgs.
Me too. It says, if you want to find me...
Look for the chaos I left in the accelerator. Wait, my accelerator's parked right outside.
Let's go check. Oh my gosh, that has to be the Higgs. Only the Higgs could leave that much energy in the Hadron Calorimeter.
What do we do, Electron?
I don't know, Talon.
Okay, I'm sick of this show. They didn't even talk about baryons and mesons.
Well, it is called Pretty Little Leptons.
What are baryons and mesons anyway?
A baryon is a particle that is made up of 3 quarks or 3 antiquarks, and a meson is a quark-antiquark pair.
What are quarks?
Oh, I know this one. Quarks are fundamental particles, and there are 6 different kinds. Up, down, side, charm, top, and bottom. Up, charm, and top all have a charge of positive 2/3, but then down, bottom, and side all have a charge of negative 1/3.
Well, what are antiquarks?
Oh, that's pretty easy. Antiquarks have the opposite charge of their counterparts. For example, an anti-up quark has a charge of negative 2/3.
Ooh, look, someone's so smart. Okay, let's go back to watching TV. Now kids, I'm going to tell you an important story. It's the story of how I met your motion.
Don't you mean how you met Mom?
No. Mr. Gallo told me that you guys have been failing his class, so I thought I'd talk to you about physics instead.
What do you know about physics?
Well kids, I learned a lot about physics from your Uncle Barney. Guys, I have the best story. I made some major motions.
Major motion.
So with that, and after a long day at work, all I wanted to do was play with my pistol. So I got it out.
Oh no,
Hold on, let me finish. So I got it out. And I was about to play with the big boy when I saw the beast. So I looked over and I saw this beast with black fur and crazy eyes. This thing wanted to kill me. So obviously, I went to shoot the ugly thing. First, I tried shooting at it at a 45-degree angle.
Why not just shoot straight at it?
I'm glad you asked. There's this equation, ax equals a cosine theta. Ax is the dart's horizontal velocity, and a is the dart's initial velocity. When theta is 45 degrees, cosine theta is root 2 over 2. That's the biggest number you can get with any angle. So when that's multiplied by the dart's initial velocity, which is the same no matter how I fire it, the horizontal velocity would be very big. With a bigger horizontal velocity, the distance would increase because horizontal velocity and horizontal distance are directly proportional.
Did it work?
No. It went a little too far. Luckily, I had another dart. This time, I aimed the gun horizontally.
Will that have slowed it down?
No. Horizontal velocity doesn't change because there were no forces acting on the dart in the horizontal direction.
So its velocity would have stayed the same?
Not quite. The dart's vertical velocity would have changed because gravity would have affected in the downward direction. Anyway, back to my story. So I aimed at the beast and fired, but I missed. That's when I tried my last option, free fall. I crept up behind the beast as quietly as possible and held my last dart right above it. Then I let go, and gravity did the work for me.
What happened to the cat?
Well, after it got hit, it didn't do anything. So I picked it up and put it outside.
That was a really, really dumb story.
No, it's not. It was legend. Wait for it. Jerry.
Well, at least I learned some more about physics. Okay, all these shows are really weird.
What the heck did Mr. Fetzko do to his TV?
I don't know, but I'm so tired of physics right now. Let's go outside.
You're annoying.
So, Brett, what is this?
Well, it's called Lightning 2000, and it has the idea of whatever that thing was that Mr. Fetzko used.
Electros? I don't know.
No, that ball where, you know, he touched his elbow and everything went to it.
Mm-hmm.
Okay, well, you can tell that when I touch it, all the electricity and everything goes to it, but because of the glass, you know, I'm not feeling anything.
Yeah.
And it's just going towards it.
So what happens when you take off the glass?
Well, because I take off the glass, the thing that was touching the metal or whatever that's making it shown here inside the insulated glass orb now has nowhere to go, meaning this is electrically charged. So if I put my elbow
Oh, whoa! That was really bright.
do you see it?
Yeah.
Can I do it again?
Okay.
It smells like
You won't.
It smells like I'm burning.
Does it hurt?
Yes. Oh, do you see it?
Yeah.
Oh.
Okay, okay. Let's stop.
Is this like a children's toy?
No, that's not meant. This glass isn't meant to come off.
I know.
So,
I use
this
this as a nightlight.
is what we do for fun when we're
I can't get it.
filming physics videos. Okay. Gotta go use the bathroom. Enemies of the Higgs, beware. You'll be next, Fetzko.